I'm Joshua Hanlon here at Brick Fair, Virginia 2017, and I'm standing inside the giant Great Ball Contraption layout. And today we're going to take a look at this one large module, one large section of the Great Ball Contraption here. So we have a couple of builders. If you want to introduce yourself and kind of take us through what we have here.
Yeah, my name is Ian Warfield. I've been coming to Brick Fair for a number of years, and been a part of the GBC for almost as long. And 1 year I just decided I had to build this giant thing, and so here we are. And I have here with me Zach. You want to say a few words about yourself?
Yeah, sure. Not long ago, I was one of the kids walking around here saying, ooh, this is the greatest thing ever. So a couple of years ago, I got into it too. I just have this problem where my modules work so well, I don't need to look after them, so I have lots of spare time on my hands. So what Ian has built here is just so amazing. I figured I would try and help out in any way I can to get it working.
Yeah, and this, I had the idea and I built it, but honestly, this would not be working now if it weren't for the help of, several people here. Zach in particular was instrumental in solving some of the problems. Mike Ty, standing right here, was also instrumental in clarifying a few of the idiosyncrasies with the LEGO IR link, or with the LEGO IR protocol used by the High Technic IR link. Another guy, I don't see him here, but his name is Connor. He also helped in terms of, sort of maintaining the roller coaster, making sure it was working, babysitting it when I had to run off into a Mindstorms contest. So I really appreciate all their help, and they were willing to stick by here and help me out. So
that's great. So it's very much team effort here. That's really awesome.
Right.
So then let's dive into the build here and take us through kind of all the different parts of this.
Absolutely. So right now it is loading up the car, and I believe it's loaded up and it's just about ready to go. So yeah, there it goes down the banking track. Someone suggested, I called it a roller coaster, but someone suggested it should be called the Indiana Jones minecart ride, because it's almost like that.
Right. Then you get a themed ride and it's more popular.
Right. I should, get Shiloh or one of the pop culture guys to see if they have an Indiana Jones minifig, and then, find a spot on the minecart to post him. So let's see. This track here uses LEGO Flex Track, and the coaster part of the module would not be possible without this LEGO Flex Track, because not only does it flex in terms of making curves that could be larger or smaller than the standard LEGO curves, it also is flexible enough to go up and down hills and to bank. And the banking is important because if this, these are turns and going down the hill and the car's going pretty fast, if it didn't bank, it would fly right off the curve. Mm-hmm. So I first got the idea when I said, hey, LEGO Flex Track is flexible enough, let's see if we can do this. And then from there, I just encountered a series of problems and implementation things, one step solved after the other. You wouldn't believe, I could talk for literally a long time about every single problem I had to solve in the course of this.
Well, what were some of the main problems I guess you faced when working on something like this? It's obviously very large. You mentioned the flex track and all of that.
Right. So I guess I want to talk about each of them in brief, and then we can go into more of them in depth. Okay. So I mentioned the flex track, which is important to have the coaster go down the whole way. I also needed a way to support the flex track, so I wanted to try to calculate the triangles to make sure it was not only the proper radius for a LEGO curve, but also would fit together with all the studs and have a connection with a bunch of towers and things. Now, I thought that was a hard problem when I was working on it. It turned out to be one of the easier problems when everything was said and done. One of the other problems was making all the structural supports to get the thing to stand up, because when you have a very tall LEGO structure, it tends to get flimsy at the top. So I used a whole bunch of these H brackets, and I just connected them with a bunch of 1x15 studless Technic beams, and those turned out to be very helpful to make a very high tower relatively easily. I also used literally a couple thousand of the black friction pins. I bought 600 of them from Stewart, and then I said, I'm going to need some more pins. I am going to buy a ridiculous number of pins, and I'm never going to use them all. So I bought 1,000 on Bricklink. Well, I used them all up. So I had to dip into my collection of friction pins and raid some of the models to get enough pins to figure all this out. So let's see. Probably enough about the structure, some of the mechanisms going on here. You'll notice that there are lots of different devices. Since the car is ready to go, I'll show you what happens when each of the things happens. You'll notice right on the front of the car is a red studless Technic beam that goes up and down when the car is ready to be released. What's actuating that is a Technic linear actuator that's doing a 4-bar linkage that makes the bar go up and down. Down at the bottom here, when the car stops, it passes an ultrasonic sensor which senses the presence. This thing that's pushing it onto the platform is another linear actuator. This dumping it is not a linear actuator, but it's controlled by the IR link. While all this is going on, the car has to be repositioned, and let me get it to sit properly on the train track. The car has to be repositioned to go back up to the top, because if the car went back up to the top in its current configuration, it would not be able to dump again when it reaches the bottom. So what I am doing here is there is a turntable which spins the car around. And again, when the turntable spins, the track may not be lined up completely. So I have a sort of device that aligns the train track here, powered by another linear actuator. You'll see on the front of the little track there is a red 3 and 5 L-shaped Technic studless beam. And that actually keeps the car trapped on the track so it doesn't slide off when it goes up and down the elevator. Now, on the other hand, when the car reaches the top of the elevator, it has to come off the elevator. And I don't want to have another complicated mechanism to lower the front L-beam when it reaches the top. So instead of having another complicated mechanism, I said I'm going to keep all the complicated stuff on the ground. And when I'm using the elevator and lifting it up, I will bank it just slightly towards the rear so that the car is rolling back towards the L-beam on the back of the platform. And that allows the car to stay on the platform, but at the same time have an opening at the front that it can go when it reaches the top. Now, once the car reaches the top, it needs to go forward again. So I just have the near and the far elevators controlled independently. So the far goes up and it tilts it forward just slightly, and then the car can roll off the platform onto the top track. And then it goes down again, and since it goes up and down, it's not connected by studs or Technic links to the turntable at the bottom. You can see here now that the platform's above it. This platform, these little angle beams here, are used for alignment to make sure that when the turntable spins around, it is lined up precisely with the track. And I need that because when the car coasts down, it has to go onto the train track properly without derailing. So those line it up. I don't know how much you can see here, but this mechanism here has a little transmission. When the platform reaches the bottom, you will see that it slowly lowers it down onto the turntable platform, and then this slider thing will slide forward, and it will actually use a Technic transmission to merge with a red 16-tooth gear, and I need that to raise and lower the L-beams. The L-beams are not raising lowered right now. That happens later when the car arrives. But again, a whole bunch of complicated machinery here. I wanted all of it on the bottom, so because it was heavy, I didn't want to support it. I didn't want it to break up in the air. I figured keep all the complicated stuff on the bottom. So, and then you'll notice all these gears and things are braced. This conveyor belt, there's a near and a far conveyor belt, and they need to be controlled separately so that the platform can tilt both forwards and backwards depending on whether it's going up or down. These are geared down pretty heavily. They are supported pretty tightly. You can see this is a parallelogram linkage that's operating right now. That pushes the car forward onto the turntable because when I use the dumping mechanism, I want to make sure the car is in precisely the right spot to dump the balls. And I also use this parallelogram linkage right up and down here to hold the car in position while this L-beam goes up on the turntable. Hopefully, yeah, there we go. So that L-beam went up. The dumper mechanism operated. Let's see. And now the turntable is going. And again, to align the train track, this slider mechanism goes back and forth. Sometimes It's like 95% reliable, so every once in a while you have to give it just a tap with your finger. But it's working much, much better now than it was when I brought it here. While this car is going back up in the elevator, I want to talk about this top platform here. You can see kind of under the track, this is a 4-bar linkage. Now, I'm not a mechanical engineer, so I couldn't really tell you much about the linkages. I mentioned the Hawkins or the Hawkins linkage over by the agitator for my monorail contraption. But the important thing about this linkage is that not only does it have to go up and down to slide through the spot in the track to be the car, but it also has to turn slightly, because if it went directly up or down, it would crash into the track at some point in its travel, not always the same point. I have here a linear actuator which pulls one of the bars back and forth, and the whole parallelogram, it's not a perfect parallelogram, but it's almost one, and that pulls the bar up and down. Another thing about this car is that you'll notice it has to transfer from a spot that approximates track, which is these two Lego Technic plates here, and then it has to go from that back onto a regular track, and since it's going onto a platform, it has to be aligned properly. So I had to use a bit of studless construction and a bit of construction with the tiles here, and you may not be able to see it from this angle with the camera, but these are sort of triangular shaped Technic studded beams, and those sort of act as wedges to direct the car forward so that it rolls on tiles so it's properly placed on the track. Now, it's supported in such a way that when it's rolling on the tiles, it's rolling on the flanges of the wheel, but they are positioned at the proper height so that when it goes onto the rails, it's supported by the rails at the same height. Now, the flanges are at different radius than the rails, which means they have to be very slightly misaligned in the vertical direction. A large number of things, every which way.
Exactly. So yeah, that's a very fascinating mechanism to get the cart up and down there, and the way that runs. So what else do we have in the rest of the build here? Kind of the other sections of it.
Okay. So yeah, that very complicated. I want to say one more thing about that. This uses a total of 9 motors. It uses 3 motors controlled by the NXT here, and it uses 6 motors that are controlled. Here is the High Technic IR link, and here are the 3 Power Functions IR receivers, and they just control all bunch of functions that do whatever they need to do in order to get the car to the right spot. There's one more motor up here, so this is a nice segue into talking about the other part. Not only is this a roller coaster, it is also sort of a bridge that goes up and down. We have here more or less a standard conveyor track that lifts the balls way up into the air. So I use those little 3/4 length pins, and when it gets to the top here, there's this bridge that just goes across the whole layout. Now, you'll notice here that this is a 2-level bridge, and the reason for that is that there's one level that goes all the way across to this spiral at the far end, and then there's another level that's on the bottom that sort of goes in this 90-degree angle so that it loads the balls into the car. Now, in order to control between the 2 levels, there's a trap door. Emmett is standing right on the trap door so that when it goes back and forth, which it's doing now, Emmett will slide back and forth, and that's kind of an indicator to the people watching, hey, look, Emmett's moving, the train is about to go. It'll give a short pause to let any remaining balls go from the end of the bottom ramp to the car, and then once it's given enough time for all the balls to reach the car, it'll release the car and the car will go. In order to switch between the top and the bottom level, there is a mini trap door here, and the trap door is very small. It's only about, 3 bricks wide, and it's made using tiled plates so that it's a very small opening, and he uses one of these mini linear actuators that, again, is controlled by the IR link. And this, it doesn't have to slide it far, it just slides it back and forth with a stroke length of 3 bricks wide. And that's enough to make a trapdoor that when the roller coaster is ready to be loaded, it'll open up that 3-stud wide trapdoor, and it'll let the balls into the bottom level to go into the car. So, so much for the trapdoor mechanism. At this far end here is a Friends slide spiral, which is something that I first saw. I believe it was Brick Fair New England 2013 when we had a giant monorail layout and we integrated the monorail with the GBC. Now, because it took up so much space in the hotel, expo center, part of the layout was a bridge that took the GBC balls. Took the monorail between like a town layout and the rest of the layout, and there was a series of elevators to go up one side of the bridge, and on the other side of the bridge to go down, there was a series of Friends slides spirals. Now, the tricky thing about the Friends slides is that when the balls go down the slides, they're going extremely fast by the time they get down maybe 2 or 3 levels. So if they're going too fast, they'll just fly right off the edge of the spiral. So what they're doing here is they'll just hit the L-beams, and that slows the ball enough that it'll just stop briefly and then go on to the next level so that it is going at a slow enough speed all the way down the spiral so it stays on the slide the entire way. Now, when the spiral reaches the bottom, you'll see it goes onto this little ramp here, and it lines up with the other ramp that connects to the rest of the roller coaster, and here is the ramp that the balls appear on when the coaster is ready to dump things out. So let's see, I believe that covers all of the major structural components. And I think I'd like to talk next about some of the problems that I ran into when designing each of these components. Since I mentioned the Friends slide, I'll mention this first. This actual L-beam thing to slow the balls down is actually maybe the 3rd or 4th design to slow the balls down. And this design is the work of Zach here. Zach has been instrumental during this entire convention in, noticing techniques that I used and then finding ways to improve them. My original technique involved Lego tires that were swinging on a beam, and those worked, but it was like an 80% solution. 4 balls would make it down, the 5th ball would go flying off. And since I was racing to get the whole thing done, I thought, that's good enough. But when you put it in the middle of a GBC layout, having 20% of the balls escape is a real problem. So Zach here, took the initiative. He had a really creative solution, and he put this L-beam thing together, and it works really well.
Yeah, I think working with Ian on this build, what it did is I think it tested both just my ability with Technic, and I'm a primarily Technic builder, so I have a lot of experience. But one thing that was new for me is really being able to collaborate, and that was something that I really think is a great skill, and something I was really glad I could practice with this, helping Ian with this.
Yeah. Zach has been a huge help during this whole convention. For instance, when I arrived, it took me a long time to actually set up the roller coaster. So I said to Zach, look, Zach, with your consent, I will deputize you. I've been bringing my monorail to every, Brick Fair for a number of years now, and the monorail itself is non-trivial to set up. But Zach has been helping with the monorail for a number of years. So I said, you know what, Zach? I am happy to give you complete authority to set up the monorail and use whatever track layout you want. Just, how it works, what is required, where to position the stations. I'm happy to let you set the whole thing up, while I take care of the roller coaster stuff. And you know what? Zach took it and went and did the monorail layout, and he came up with a really nice layout that not only met the standard requirements, but also looks cool and has a couple other, non-essential but also neat features like, having switches in the middle to make the track layout more interesting.
Yeah, that's really great that you two were able to work together on this like that. I think it's so great when builders can collaborate and make something better together neither of them would have been able to do by themselves.
Right. Now, another thing about this roller coaster is that it was a lot of work to build, and I knew it was a lot of work before it started, but things always turn out to be more complicated than you expect, even when things are more complicated than you expect. That, I believe, is Hofstadter's law. even when you take into account Hofstadter's law, it's still gonna apply to you. Now, these, let's see. When I knew I was going to build the roller coaster, I said, I'm going to spend every spare moment, every free moment in every weekend in July building this thing before I get here. And I took the week off before leading up to Brick Fair, and I ended up pulling 2 all-nighters in a row to get the thing built in time. I thought to myself, silly self, I will build this whole thing during July, and then the week before Brick Fair, I'll just test it so that it's working perfectly when it gets here. No, not at all. The first one technically wasn't an all-nighter because I got 3 hours of sleep, but the second one was a true all-nighter. And I just had to build one thing and one thing after another. So I got the thing here, and if you look at this elevator, you notice when the train reaches the bottom, the elevator has to raise the near section and the far section independently. Well, the original design of the elevator had these conveyor belts oriented 90 degrees from where they are right now. They were originally, they're parallel with my hand. They were originally perpendicular with my hand. The conveyor belts were this way, and they were going up, down here, and then up, down on the inside and the outside. That had the unfortunate effect that I had to synchronize the left and the right. With the current design, the left and the right are connected with the axle, so they don't need synchronization. But in order to fix that, I had to rebuild the entire elevator section. That actually took all of Thursday and Friday to just rebuild the thing. And again, Zach was instrumental in noticing several things during the elevator's construction. Zach, do you want to talk about something about the elevator's construction that you noticed?
Yeah, sure. So I noticed one of the things, I use these pieces a lot when making GBC modules, chains. I love them, they work great, and I have a whole bunch of them. But one of the things I tried personally, and I noticed what Ian had tried, is he had used the large, I believe it's a 40-tooth gear, and he was driving it with the small 8-tooth gear, and he had that axle running all the way across to the NXT motor. Now that's great because it's simple, it's a great gear ratio, but there's enough clearance to allow the gear wheel, or the sprocket wheel, to clear that axle, but not enough clearance to allow the chain along with that. So I noticed he had assembled it, he hadn't put the chain on, that's something you would do last. So I pointed it out to him, and what he did was great. He just added another set of gears. It gears it down even more so it has even more torque. And I think it's a great example of just different ideas from different people leading to the best possible solution.
Definitely.
All right. So I've got a couple of gears here that I wanted to, of course I just dropped one. Let me get another one. You'll notice that the design of the elevator is geared down quite substantially right now. There's an 8-tooth going to, I don't know how many teeth is on this medium-sized gear, and then another 8-tooth going to this large gear here. And that's a lot of gearing, and that's important because, the track assembly is heavy and the car is heavy, and it needs to be controlled very precisely when it's going up and down, and moving slowly with a lot of torque is very important for that. Well, originally, there was very little gearing at all. In fact, I have in my hands 2 gears. These little gears here were just, that was the extent of the gearing. That was it. And the problem here is that it was so heavy that this crown gear would slip quite often. And that was just a problem because the elevator has to be positioned very precisely at the top floor in order to let the car off at the right spot. And when this gear slipped teeth a few dozen times, you'd end up with the car on top of the top floor, and the left side would be higher than the right, or it would be letting the car off a little bit too low and it would miss the track entirely, and it was just a mess. So that was the condition it was when it arrived here. So I ripped all of that out. At one point, this entire table was covered with the guts of the elevator, and I just took this completely inadequate single gear reduction thing that was very complicated, and I turned it into, and not me specifically, I'm saying me, but it was a team effort, this much better gearing system that works better, and even though it uses more parts, it is conceptually simpler, and it works much better than the other elevator system.
Well, that is fascinating. I love the detailed explanation there and kind of how that all came together. And I think in the end, it seemed to end up working fairly well. It looked like the balls were moving through.
Yeah, it actually works extremely well. Not only does it work, the 80% solution, but Zach, again, has been throughout the weekend finding little bitty ways to improve on things. For example, you can see here this loader mechanism. Again, this was during the end of my all-nighter, so I said, second all-nighter. So I said, I'm just going to build a no-frills loader mechanism. If it works, fine. Well, Zach added this little agitator thing here that agitated the balls just to get them so you wouldn't end up with clogs, which is important because any GBC that collects a lot of balls is going to need an agitator. I was like, forget the agitator, I just want to get this done. Zach took the initiative again, and he built this agitator. He also made a number of other construction improvements, like adding these 2 wide cheese plates here, so that if the balls were going up, they wouldn't fly off all over the table. They'd go right back in the right position. He added these boatways to kind of hold the thing down so that the conveyor belt wouldn't yank it up. He added this whole Technic beam construction that's going inside the conveyor belt all the way up. And that sort of braced it. It served 2 functions. It braced it so that the loader would stay the proper distance away from the tower. And it also aligned the track because previously it was shaking forward and back, and it was also wobbling a little bit left to right. So this cuts down both the shaking and the wobbling to much less than it was.
Mm-hmm. Yeah. Well, that's a great process there. So it looks like you guys finally got it working after all that. And I appreciate both of you kind of taking us through the giant module here. Thank you.
Yeah. My pleasure. Honestly, I am ecstatic that everything all came together. I did this specifically for the purpose of winning a Brickie. I said, I'd never won a Brickie before, so I said, I'm going to go all out. I am going to build the biggest, bestest GBC module. Yes, it's complicated, but it's not needlessly complicated. Every function has a purpose. Everything, there's nothing here that is not needed. Everything here does what it's needed, does what it has to do. And to my chagrin, I did not win the best GBC module, probably because at the time voting was happening, it still wasn't working. So people said, I'm not voting for a non-working GBC module. What are you talking about?
That is kind of an essential part of GBC, that the module actually work and move the balls.
That's and in retrospect, that was the right thing to do, because voting for a GBC module that doesn't work is kind of, a GBC module by definition has to work. Well, by Sunday it was working. So, I really appreciated the fact that it was selected as one of the staff favorites here at Brick Fair.
Congratulations on that. You did end up with an award.
I did. I'm really grateful for that. They didn't have to do it, but I'm really glad they did. This whole thing has been one fantastic adventure from start to finish. I love solving problems, and boy, did I have a lot of problems to solve with this thing. Again, it wasn't only me. It was, once I brought it to the convention, it needed a great deal of work, and there were a lot of people here who were willing to step in and help me out. Oh, and one more thing. The process of rebuilding the elevator required a ton of extra parts, and I rated a ton of Stuart's parts with Stuart's permission. Stuart Roll gave me permission. He said, use whatever my parts you need to get it working. He said, I said, I may need to use a lot of parts. And he said, that's okay. I used a ton of parts, and I really appreciate that Stuart brought all his parts, because if those parts were not here, I would not have been able to. So again, many, many factors here all coming together to make it a success. And I'm really grateful to my fellow GBCers for helping me do it.
Definitely. Well, thank you, Ian, and thank you, Zach, for taking us through the module here. Appreciate it. Thank you, guys.
My pleasure.